Hello, physics. Nuclear physics, radioactivity. Problem is a sample of 1.49 microgram of nitrogen N713, half life 10 minute 600 second. What is the number of initial nuclei at t is equal to 0? Initial activity at t is equal to 0. Activity at 60 minute, after 60 minute, and how long it will take to reach the activity of a nucleus, one nucleus per second. So first of all, we have to find initial number of nuclei. So this is equal to, so 1. So is Avogadro number n naught over Avogadro number, which is equal to 16, 6.02 into 10 to the power minus 23 plus 23 nuclei is equal to uh, that number 6.02 correspond to 1 mole of nitrogen, which is 13 gram, over what is the number of 1.49 microgram. So it is equal to 1.49 into 10 to the power minus 6 gram over 13 gram. So from here, n0, we can calculate the n0. N0 is equal to 6.0, 6.90 into 10 to the power 16 nuclei at t is equal to 0. Number 2, initial activity. So activity, for this initial activity, we have this one formula, delta n over delta t. This is activity at t is equal to 0. That is proportional to the initial nuclei. From here, we have to find, this is equation 1, we have to find n, lambda. Lambda, so for lambda is equal to 0.693, 69.3% of the time, which is a 600 second, which is equal to 1.16 into 10 to the power minus 2 uh, second inverse. Second inverse. Is this is inverse. So this is the lambda. So from there, we can find this activity. So this is equal to 1.16 into 10 to the power minus 2 per second, and n naught is this one, 6.90 into 10 to the power 16 nuclei. So this is equal to 8.0 into 10 power 13 decays, nuclei per decay per second. So that is activity at t is equal to 0. Number 3, after 60 minute, so half-life is equal to 10 minute. So after 60 minutes, that means 6 into 10 minutes. So that will be 6 time. So 1 by 2, 1 over 2, 1, 2, 3, 4, 5, 6, 64. So that means uh, how much is the decay at the initial? So 8.0 into 10 power 13 decay per second multiplied by this 60 minute is 1 over 2 raised power 6, which is equal to 1.25 into 10 power 12 decay per second. So that is the answer. Or this can be solved like this one, delta n over delta t at time t is equal to delta n over delta t times 0 into e raised power minus lambda t. So from here it is equal to, this is equal to, this we have already used, this one, it is equal to 8.0 into 10 power 13 decay per second into e raised power minus lambda is equal to 1.16 into 10 power minus 2 into t is 600 second. So uh, if you calculate this one, and this is a just number, and it will be also 1.25 into 10 power 12 decay per second. This is another root. Number 4. What activity will be what will be the time? So delta n over delta t, if it is equal to 1.0 into decay per second, so we have to find the time. So this will be equal to delta n over delta t time t is equal to delta n over delta t at 0 e raised power minus lambda t. So t we have to find, and that is given, that is equal to or we can find out e raised power minus lambda t is equal to delta n over delta t over delta n over delta t 0, or from here if we want to simplify, t is equal to minus ln, or this will be equal to this number uh, delta n over delta t over delta n over delta t 0, this one over lambda, this is equal to minus ln into 1.25 into 10 to the power minus 14 over lambda, which is lambda we have calculated this 1.16 is the 10 to the power minus 2. So we will find this one, and this is equal to 7 2.76 into 10 to the power 4 second, which is equal to 7.67 hours. This is the answer of this question.